I thought I'd give you just a quick intro to the technology that we have. You have two links in our Blackboard page, Sagemath cell and Desmos calculator. I don't know how much the Desmos calculator will come in handy on the actual complex things, but it does have its purposes at times that would make it a nice tool to use. Certainly if you just need to do a quick calculation. But there are some other things too. So let's start with the Sagemath cell, and so I click that, and I have something started here. Let me make that just a little bit bigger. Okay, so I'm using Z because it's a complex variable, and so I'm going to put some comments in here. Here I've got these commented out, so we'll get to those in a minute. But a comment is simply started with a pound sign or a hashtag sign, and so this first line, the var Z, is just what I'm doing here is I'm declaring Z as a symbolic variable, so it doesn't have to have any particular value. So then what I want to do is solve the quadratic equation, quadratic equation, z squared plus 1 equals 0, and assign the output to S. Excuse me. Okay, so that's this next thing, and then once I do that, I'd kind of like to see the answer. So the show, that particular command is to make it kind of pretty. You can always try print. I'm not going to do it right now, but it's just not as pretty. And so we would like to show the result S. Okay, so those are three commands. I need to let it know that I have a symbolic variable, because otherwise it won't know what to do with this Z here. And I didn't need to declare S as symbolic because it's just being assigned something. And then I want to see the answer, so I say show. That was the output, but I'll click evaluate just to see it again, and it says Z equals -I or +I. Okay, right? The square root of -1, because what would I do? I'd move 1 over to the right hand side. That would make it a -1. I'd take the square root of both sides. I get the square root of -1, either plus or minus. And notice, here I said equals 0 just the way you would normally write it, but here I had to use a double equal sign to actually mean equals. A single equal sign like this, see, is an assignment. So these are just some things we need to know about technology, but we'll get them. Now notice, and so we'll see some more things. Here I have the answers, -I and +I. Well, what if I wanted to get to those or parts of those? Sorry, my asthma and so forth is acting up terribly, but in order to get to this, so you see it's in square brackets. So when something's in square brackets and I've got a comma here, it's actually a list. And so here's the first item in the list and the second item in the list. But the way Sagemath and many other computer programs work, the first item in a list is actually item 0 and then item 1. So here I'm taking S0. Okay, so I'll write this down. Okay, so get item 0 of S. Okay, so that's that first part, S of 0. And then you notice that first item, it's an equation. Well, I don't want the whole equation. I want just the answer, the right-hand side. So get item 0 of S, then get its right hand side. So notice that's just RHS from that. So, you know, things are relatively intuitive. And then once I have the right hand side, I thought I'd go ahead and show you that we can get the real part and the imaginary part of a complex number. And so then its real part, and assign to x0. So, you know, that's what I did for that first part. I'll do the same for the imaginary part. So I did a Control-C to copy, Control-V to paste my comment. Get 0, that's all the same. Then it's imaginary part. Now, and I've used this a lot, but I haven't actually used it that much for complex numbers, a little bit. But I didn't remember that actually I really could just do that to get the real part, but I just sort of guessed I could. And I thought, you know, probably it's just real because that's a pretty short word, and so I went with that and it worked. Then for the imaginary part, okay, I did the same thing, and I thought, you know, imaginary is a pretty long word, so I was guessing it was just imag, and I guessed right, and so I got that right. And now I'll show both results together, separated by a comma. And so I had to put the comma in quotes, but I'll take that out. And so the real part of this is 0, the imaginary part is -1, and so hopefully that's what I'll get. 0 for the real part, -1 for the imaginary part, and there we go. Okay, and then I do the same thing for okay, and so I repeat for item 1, and so I'll get rid of those comments, evaluate, and I should get 0 and 1. So, you know, this is a nice technology. We can do all kinds of nice stuff. Now again, let's go back here and just let me try print. Okay, and evaluate. And see, that's just not near as pretty. It's there, but it's not near as pretty. So we'll go with show. Now, there are actually a couple different languages you can use in here. Well, actually many languages we can use inside this cell. So at times when we're not doing symbolic stuff, we might do other types of things. But let's just let's try something here. I haven't tried this. We'll just see what happens, but I'm kind of curious. For one, just I want to see if something works the way I hope it will. Notice now here it used an uppercase I, so I'm going to assume that I need to use an uppercase I if I want to use the square root of -1. So here I'm going to add in here x and y as symbolic variables, and down here I'm just going to try something like now I've already used the z, so I'm going to use a w equals x plus I, and I do have to use a time symbol, y. So I'm going to try that and then show w. Now I could just say show x plus I, y. Mostly I'm just trying to see, does this work? Okay, and I evaluate. And the worst case is it won't. But see, there it does. It says that's x plus, it knows what that is. And so it would be interesting now to just repeat this first part, the solve and the show. So I'll Control C to copy, Control V to paste. You know, it might be interesting just to see. Instead of S, maybe I'll call it U, something like that. But here I'm going to do W and solve for W and show U. And I'm going to get rid of this comment. And let's just see if it gives us the same. Now that's interesting. It didn't seem to like that. It didn't seem to know what to do with that. See, so you know, these are good things to know. Okay, or you know that it didn't seem to know what that was. But we can try some other things. So like we know about the conjugate. So I've got show W, show. Now, I would guess it's something like conjugate. How about CONJ and the parentheses because it's a function, and I'll get rid of the show U because now it doesn't have any idea what that is. Let's see if that works. And so you can always experiment with stuff. Now you don't want to. Yeah, now here's a case where something didn't work. And it says it has no attribute. It doesn't know what I'm talking about. Okay, so, you know, if you run into that, and I haven't done it on, say, a video or something like that, and you're just trying to figure something out, you can go, I like going to Google as opposed to the Yahoo search. You can go here, and what I always do is I say Sagemath, and then I'm just going to say conjugate. Complex conjugate of a variable, ask Sage Q&A forum. Sounds like a good place to go. And usually one of the first 2 or 3 results is going to work. Have to use the whole word, and it's not a dot thing. You have to put it in there. Okay, so I don't know where this came from, but he must have defined x somewhere, something, I don't know. But let's see, oh wait, well that's his question, so maybe down here they say 2 plus 2i. I have no idea. I'm not sure that answers anything, but we'll just try doing it that way, saying conjugate W see if that works. No. Okay. Oh, I left the silly me. Of course it didn't work. Oh, there we go. Now that's interesting. So you see what it did here? It did the minus on the y part as it should have, but it assumed, because I didn't tell it any differently, that x could be a complex variable, so it made it a conjugate, and it assumed y could be a complex variable, so it made it a conjugate. So that's interesting. So it'll be interesting now to just look at, well, okay, what if I did w times w conjugate? Just to see what sort of the answer looks like. Yeah, see, it didn't actually multiply it out the way I would hope. So that may take some looking into as to how to make all that work. But I will show you one other thing. So here I used an I, but actually another way I could have done this was it's a little funny how you have to do this. You can use a lowercase j, but if you do just a j by itself, it won't know what you're talking about. I think we'll get an error here if I say evaluate. Yeah, see, j is not defined. But if, in this case, if I say 1j with no multiplication symbol, and I say evaluate, now it knows what I meant. It puts a 1 there, which is a little ugly, but notice it put an I. It knew what I meant. So you can also do that kind of notation. Now, in this case, well, it seems a whole lot easier just to use the uppercase I. So that's a good thing. It just makes my life easier. But yeah, we'll have to look at that. We've got to look at those sorts of things. But I just wanted to show that we have this technology that can do algebra with complex numbers. Now, Desmos, which you're probably familiar with, it's not so good. So here I put in the square root of -1, and it said, I don't know what that is, right? And on the actually, we should look at that. So let me get rid of this and say square root of -1. It might just say square root of -1. I'm not sure. I don't think it'll give me an error. No. See, it gave me I. Okay. So you see, it knows complex numbers. Desmos doesn't. But on the other hand, Desmos is very, very good at graphing. And so, for instance, when we start looking at curves, more parameterized curves within complex variables, and we need to define x as something and y as something in terms of t. Well, here, I can just say something like, well, x is cosine of t, comma, y is sine of t. And, oops, of course, I was thinking y and typed it. Y is sine of t. And it gave me that curve. It said, well, start at 0. Well, I can change it to go to 2 pi. And, so I can see a parameterized curve for x and y. So x is, I do that by using cosine of t. I create my y variable by doing sine of t. And if I look at all those ordered pairs from t equals 0 to 2 pi, I see that I get a circle. And so that is an awesomely convenient way to look at parameterized curves. You can do it within Sagecell as well, and it's not that hard. But this is just way easy to if I wanted to look at a curve. Okay, so that's just kind of to show you really quickly that we have some very powerful technology that can help us quite a bit in this course in the beginning, certainly with complex variables. So we'll say that that is enough for this video.